Hello, in this video we're going to talk about the relationship between the z-score, the empirical rule, and percentiles. Our main goal is to use the z-score that we calculate for specific pieces of data and the relationship the z-scores have to the empirical rule to find the percentile that's appropriate for each z-score. So to do that, we want to start with some data and we're going to calculate a z-score. So this problem in the homework tells us the lifespans of a species of fruit fly have a bell-shaped distribution, or a normal distribution, with a mean of 33 days and a standard deviation of 4 days. Then it asks us to compute the z-scores for 37, 29, and 45 days. So Excel has a built-in calculation for z-score called standardize. But if we wanted to use the manual calculation for z-score, we can. It would be the individual piece of data minus the mean divided by the standard deviation. What we really care about is what the z-score is. This calculation is detailed in the page, The Importance of Z-Scores, and explains that using the calculation means that we'll have units over units, which cancel, to give us a unitless measure of the distance that a data value has from the mean in terms of standard deviation. If we understand what we're going for, then how we calculate it doesn't really matter. What matters is how we apply the result. So let's focus on that. Using the built-in calculation for the z-score from Excel, we need the mean and the standard deviation. From the problem, we can see that the mean is 33 days and the standard deviation is 4 days. I also need to be able to input values because I need to find several z-scores. So I'll put values on this side and z-score on this side. What I want to do is take advantage of Excel's ability to replicate a calculation combined with this mean and standard deviation. So I'll manually type in the values 37, 29, and 45. 37, 29, on the next cell, and 45. And I'm getting those values from the problem. It asks me to find the z-scores for 37, 29, and 45 days. To calculate the z-score, I'm going to use something called standardize, because what it does is take the z-score from our set of data that does not have the standard normal distribution, meaning a mean of 0 and a standard deviation of 1, and converts it so that it does have the standard normal distribution. So equals standardize. Remember, I can either double-click or hit the tab key to have the equation fill out. Standardize is looking for the value x, the mean, and the standard deviation. So this is my individual value for my data set. Here is my mean, and here is my standard deviation. I'm separating them with commas, just like the pop-up has asked me to do. It represents commas in between each one of these. Okay. If I just hit enter and try and drag down, what will happen is that the blue box will move down like I wanted to, but also the red and purple boxes will move down as well. So I can demonstrate that. If I bring this down, I run into issues. And that's because at this calculation, they're using 29 like I want them to, but unfortunately it's using this red box and this purple box instead of this one and this one. To fix that, I can tell Excel to never leave those particular values. In order to do that, I need to lock the value with a $sign. So I can type a $sign here, and that just tells Excel don't leave. Always this cell. So even if I drag it down or sideways, it will never leave this red cell. An easier way to do that, besides manually typing in the $signs, is to click anywhere in the cell name that you want to stay with, and use the F4 key on your keyboard. Let me bring up the on-screen keyboard so you can see the F4 key. So if you're using a regular keyboard, there should be an extra line of function keys at the top. If you're using a small keyboard that would come with like a tablet or a very small laptop, then you usually have to use this Fn key to activate the function keys. So if I select F4, you can see it adds all of the $signs for me. And so it's just an easier way than typing in the $signs manually and trying to make sure that you get them all in the right spot. So again, if I just select F4, it will type in the $signs for me. So I'll delete them from this cell. Click anywhere in here, so in front or behind or in the middle, and hit the F4 button. The $signs appear, and now it will not leave the red cell and it will not leave the blue cell, but since the purple cell. But since the blue cell does not have any dollar signs, that one will drag down like I want it to. So now when I drag it down, those value errors will go away, and I'll get actual z-scores. So now I just need to go to the homework problem and enter those z-scores. So I have 37 days is a z-score of 1. 29 days is a z-score of -1, meaning that it's below the mean, which makes sense because the mean is 33. 29 is definitely below 33, so it should definitely have a negative z-score. Okay, and then 45 is 3 standard deviations away, and just check that that seems reasonable. The mean is 33. 45 is definitely larger, so it should be positive. The standard deviation is 4, so to get from 33 to 45, it's going to take quite a few standard deviations. I'm going to have to add 4 a number of times before I get to 45. Specifically, I'll have to add 4 3 times. That's what the z-score is telling me. That 45 is exactly 3 standard deviations above the mean. Okay, so now it's going to ask us for which ones are unusual. So let me zoom out on this problem so we can see the options easier. It says select all of the lifespans that are unusual. Going back to the importance of z-score, page, or announcement, we have calculations for very unusual and unusual. Those are based on the empirical rule. The empirical rule tells us, if we look at a more simplified version of this, that we essentially have 68% of the values between 1 standard deviation above and below, about 95% of the values between 2 standard deviations above and below, and about 99.7% of the values between 3 standard deviations above and below the mean. So based on that outline, I can see that it seems reasonable to be within 2 standard deviations of the mean, because that's where 95% of the data is. There is this outlying 5% of the data, so 2.5 above and 2.5 below, that are unusual. Typically in statistics, when something is around 5%, we say that it's not usual because it happens not very often. So for example, if I told you there was a 5% chance of rain tomorrow, you probably wouldn't pack an umbrella. But if I told you there was a 95% chance of rain tomorrow, you would pack an umbrella. So you can think of this as the 95% chance of rain is sitting in here, right? And then the 5% chance of rain is out here. Okay, so because of that empirical rule, we've simplified that into this graph that only has a number line. So unusual scores are between a z-score of -2, 2 standard deviations below the mean, and a z-score of +2, 2 standard deviations above the mean. The same goes for outside. So unusual scores are between -3 and -2. So 3 standard deviations below and 2 standard deviations below. The same for the positive side. And then outside of those 3 standard deviations, we're talking a very tiny percentage. There's 0.15 on either side. So less than 1%, including both above and below. So it would be very unusual to have a value outside of that. So going back to the homework, it asks us for what value would be unusual. And we can see that 45 is very far away from the mean. It's 3 standard deviations away. So 45 would be an unusual value, whereas 37 is within 2 standard deviations and 29 is within 2 standard deviations. So now it asks us for the more complex problem, determine the percentile using the empirical rule. If you recall from the definition of percentiles, these are the areas that we make a cut to separate percentages of the data. So for example, the 95th percentile would separate the bottom 95% from the top 5%. The empirical rule does that same thing. It's separating percentages of data. So if I add up all the percentages below this, then I get a percentile with this amount of percentage below and this amount of percentage above. So let's copy this and we'll add it to our Excel spreadsheet. You can just paste the image directly into Excel. So what I'm going to do is add the percentages as accurately as I can below. So here I have 0.15, and then 2.35, 13.5, I'm starting to get out of line, 34, 34, 13.5, 2.35, and 0.15. Let me see if I can move this and stretch that out so it lines up a little bit better. That lines up pretty good. I can live with that. Okay, so if I'm, say, 1 standard deviation above the mean, or let's actually start right at the mean. If I'm right at the mean, then I should be splitting the data in half. So the mean for this perfect bell-shaped curve should be the same as the median, which is the same as the second quartile, which is the same as P50. They're all different ways of saying what's the middle of the data. Okay, and if I add up these percentages and use my quick add at the bottom right here, I can see that the sum of the percentages is 50. So in other words, 50% of the data is down here, and over here, 50% of the data is up here. So let's try one of these z-scores. So a z-score that's 1 standard deviation above. So that means it's making a cut right here. So I can just highlight these sums to find the percentage below. The percentage below is the same name as the percentile. So if I highlight these, I can see I get 84. So right here, 1 standard deviation above is the same thing as the 84th percentile because it's separating the bottom 84% from the top 16%. So going back to my homework problem, it wants to know the percentiles using the empirical rule for 37, 41, and 25 days. First thing to note is that I haven't found all those z-scores yet. I found 37, but I don't have 41 or 25. So I can add them, 41 and 25, and just continue to drag down that formula to make the z-score calculations for me. So I have 2 and -2. So now I can use those z-scores to find the percentile for each. So let me go ahead and highlight the ones that I'm looking for so I don't lose track, and reopen this. So right here, I'll name this column percentile so that it doesn't get covered by my image. And I want the percentile for 45, which is the same as the third, did it say 45? 37. That seems weird. Okay, never mind, no fill there. And we want this one. Good thing I highlighted them. There we go. So 37, 41, and 25. Okay, let me move this up. And we'll start again. So I need the percentile for 37, which is 1 standard deviation above the mean. And I've already found that percentile, but just to show how to do it one more time, I'm going to highlight all of the percentages and use the quick add in the corner to find that the sum is 84. Let me turn on my magnifier and see if I can help you see that sum down here in the corner. So it's telling me that the sum is 84 right here. In fact, I can zoom in even more. 300%. So the sum is 84. Okay, so this is the 84th percentile. Now going to 41, it's 2 standard deviations above the mean, so I need to go to 2 standard deviations above the mean. It's making a cut right here. And now I have options. I can either highlight all of these, which is 97.5, or I could highlight these two and subtract that from 1, because all of the percentages should add up to 1. We can double check that. All of the percentages have added up to 1, or 100%. So if I just take these two and add them up and subtract them from 100%, I should also get 97.5. So at the second standard deviation, we're at the 97.5 percentile. Now for 25, we're 2 standard deviations below, so we need to go make the cut over here. Sorry, over here. At 1, 2 standard deviations below. So I need to highlight these two down here, and it essentially gives me the opposite side. So it should be 2.5. You may have noticed that you could have just used symmetry to find that. So if these all add up to 97.5, and we know that these two add up to 2.5, then it shouldn't matter whether you're above or below. Symmetry should still give you the same answer because the graph itself is symmetric. So in other words, if this is 50, this has to be 50. If this is, let's see, 16, then this has to be 84, right? And if this is 16, one more, 84, then this has to be 16. So there's symmetry in the graph that we can use with the fact that they all add up to 100% to make sure that our calculations are the same and to save us some time in our calculations. So let's go back to the homework problem. I'm going to enter 37 days, double check that I have 37 and not one of the other values. That's the 84th percentile. 41 days, that's the 97.5 percentile. And 25 days is the 2.5th percentile. It's a weird way of saying that. We can do one more reasonable check, and that is 37 is above the mean, but not very much. Okay, so 84th percentile seems pretty reasonable. 41 is a little bit more above the mean than 37, so it should have a higher percentile. Okay, and since 25 is far below the mean, then it should have a very small percentile. Awesome. I hope that helps you make the connection between percentiles, the empirical rule, and z-scores. And keep in mind that z-scores will keep coming up and the empirical will keep coming up as we move forward in our class. It's a very important relationship to establish between these two. So for example, if I were to ask you what value gives us the 84th percentile, you would be able to just go highlight until you have 84, and then find the value that corresponds to the first z-score. So you could backwards engineer the z-score by solving for it. All right, I will see you in class.